Welcome, friends. I am Dr. J. Juliet Josephine Joy, Professor of Physics, Science and Humanity Department from Hindustan College of Engineering and Technology. We are going to discuss about the hysteresis based on domain theory. Here we have to see what is hysteresis. Hysteresis means lagging behind. When a ferromagnetic material is subjected to cycle of magnetization, intensity of magnetization and magnetic induction lag behind the magnetizing field. If an alternating magnetic field is applied to the material, its magnetization will trace out as a loop that is called the hysteresis loop. When a ferromagnetic material is subjected to an external magnetic field, there is an increase in the value of the resultant magnetic moment of the specimen. This is due to motion of domain walls, rotation of domain walls. When a small external field is applied, the domain walls is displaced slightly in easy direction of magnetization. This gives rise to small magnetization corresponding to the initial portion of the hysteresis curve OA. Now, if the applied field is removed from this, removed, then the domain returns to its original state. That is called the reversible domain or reversible wall displacement. It denotes OA. When the field is increased, large number of domains contribute to the magnetization this time, and then the magnetization increases rapidly with H. Now, from here, now even when the field is removed because of the displacement of domain wall to a very large distance from A to B, the domain boundaries do not come back to the original position. This process is indicated by AB, and this distance is called the irreversible domain or irreversible wall displacement. At point B, all domains have got magnetized along the easy direction. Now, when the field is increased, the domain start rotating along the field direction, and anisotropic energy is stored in the hard direction. It is represented by BC. Thus, the specimen is said to attain maximum magnetization. At this position, even after the removal of the external field, the material possesses the magnetism that is called the residual magnetism, that is, or retentivity. It denotes OD. Actually, after removal of the external field, the specimen will try to attain the original configuration by the movement of Bloch wall. But this movement is stopped due to the presence of impurities, lattice imperfections, etc. Therefore, to overcome this, a large amount of reverse magnetic field is applied to the specimen. The amount of energy spent to reduce magnetization to zero is called cohesivity. It denotes OE. Then we have to see what is hysteresis loss. Hysteresis loss means it is a loss of energy taking a ferromagnetic specimen through a complete cycle of magnetization, and the area enclosed is called the hysteresis loop. Based on this area of hysteresis loop, the magnetic materials are classified into two: soft magnetic material and hard magnetic materials. If you have the application, magnetic material having a wider hysteresis loop is used in the device like magnetic tape, hard disk, credit cards, audio recordings, as its memory is not easily erased. Magnetic materials having a narrow hysteresis loop are used as electromagnets, solenoid, transformers, and relays, which require minimum energy dissipation. Thank you.